Welcome back, learners. So now moving on to our application questions, and remember they are still based on resistors. The first application question given to us is we need to name 4 factors that influence the resistance of a conductor. So the resistance of a conductor is influenced by 4 factors. Now those 4 factors are, number 1, in no particular order, we have temperature, we have type of a conductor or type of the material, number 3, we have the length of a conductor, and the last one is the thickness of a conductor. Now the next question on application question says, when the electrons move through the filament, they experience high resistance. This means that they transfer a lot of energy to the filament when they pass through. So we need to now describe the energy transfer that is taking place. So remember, as the electrons are moving through the filament, so they are moving in a form of electricity or electrical current. Now as they are passing through the filament, and the filament has a high resistance, now the resistance between the conductor, in this case the filament, and the electricity generates heat. So in other words, the energy transfer will be moving from electrical energy to heat energy. So this is now moving from electrical energy to heat energy. Now, because this is a filament, it's not only just going to be heat, there's also going to be light being generated there. So it's going to be electrical energy to heat energy and light. So, and light. There we go. So as those electrons are moving through the filament, there's going to be a resistance between the flow of the electrical current and the conductor, being the filament. Now, because the filament, as we have said, has a high resistance, there's going to be heat that is going to be produced as a byproduct, and that heat is going to be lost as energy in that particular generation of electrical current. Now, not only will the heat be produced, also light is going to be produced during that struggle of the flow of current through that filament. Question 3 is asking us now that what is the useful energy output and what is the wasted energy output in this light bulb. So as we have said, as now that electrical current is trying to pass through the filament, there's going to be 2 things being generated. We're going to have heat, and we're also going to have light. Now remember, the main aim of a light bulb is to produce light. Now what we don't want a light bulb to do is to produce heat. So basically, what is useful in that particular light bulb, or in that output of the 2, is our light. So light is the useful energy because that's what we want. However, what is wasted energy is the heat, because we are not looking for the heat from that particular light bulb. All we are looking for is the light. So to answer now the question, the useful energy output is light, and the wasted energy output, that's heat, because we are not looking for, whenever we are switching on a light bulb at our home, we are not looking for heat, we are mainly looking for the light bulb, the light that is going to be generated when that resistance is taking place between the resistor and also the electric current as it is flowing through. Now question 4 is asking us, we need to look at the photo of a toaster that we have alongside. Can you see the glowing filament inside? So we can see that there's a glowing filament there inside. So why does this filament glow? Remember, the reason why it glows is because of the high resistance of the filament. It generates light and heat as the electric current flows through it. So as the electric current flows through the filament, the resistance is going to generate the heat and in turn also generate the light bulb. Now question is, what is the useful output energy in this system? So in a toaster, whenever you want to toast your bread, what you want is heat that is going to be generated from the toaster. What you don't want is the light. So a light is just a byproduct. It's just there because it needs to be generated because of that resistance between the conductor and the flow of current. However, the useful output that you need from a toaster is heat energy. So the useful output energy here is going to be your heat energy. It's going to be your heat energy, if you can call it that, because that's the main reason why you put in your bread in there, so that the toaster can generate heat and therefore toast your bread. You don't want the toaster to light up your bread. That's not what you want. You want the heat. Now moving on to the next question. What is then the wasted output energy in this system? As you've said, you are looking for the heat, you don't want the light. The light is just there because it has been generated by the resistance between the conductor and the flow of current. So what is the wasted output here? That is going to be your light. That's not what you were looking for. When you put in your bread there, you did not say you want the toaster to light up your bread. You merely wanted the toaster to heat up your bread and therefore in turn toast your bread. So with all of these questions answered, and before we now move on to the next part, we're just going to quickly go for a short break and I will see you just after this.